Good morning to all of you, my dear friends. Myself, Dr. Rajaram Patil, Convener, Department of Geography. Dr. Balaji Suravse, Convener, Department of Economics. And our Principal, Dr. Satish Kamath, Organizing Secretary. We welcome you to online international interdisciplinary conference on the role of economy and ecology in sustainable development. We are grateful to our chairman Sri Srikant Apte, Secretary Sri Manish Gandhi, Treasurer Sri Samir Mangle, Director of Phondaghat Education Society for their constant support and encouragement. Dr. Suhas Pednekar, Vice Chancellor of University of Mumbai, Dr. Sanjay Jagtap, Joint Director of Higher Education, Konkan Region, Maharashtra, Dr. Bhalchandra Munagekar, ex-Member of Parliament, ex-Member Planning Commission, Government of India, are our respected patrons. We are thankful for their constant help and support to us. Mr. Scott Kafora, social worker and architecture, Texas, USA. Professor Dr. Shishank, Director, 4th Industrial Revolution Technologies Center, Birmingham, University, UK. Professor Dr. InibeheUpkong, Department of Agriculture, Extension and Management, Federal Polytechnic, University, Nigeria. Dr. Praveen Saptarshi, Professor and Co-Ordinator, Salisbury University, Maryland, USA, are the guest of honor for this function. Our institution has organized online international interdisciplinary conference during this lockdown period of pandemic COVID-19. We all have taken experience of lockdown during this period. Every sector is going through difficult situation. Many changes are taking place which are facing globally. Challenges and changes are dominant in the field of economy, agriculture, tourism, migration, population, cooperation, education, poverty, communication, services, trade and finance, etc. Most of students and academicians are doing their job and work from home. Nowadays, online system is helping and supporting all of us. Webinar helps us interact people and exchange information of global level. All our reputed resource persons will be sharing valuable opinion in this online conference. Many participants are submitting their opinion and ideas in the form of research papers. We got very good response from all over India. Now I request our principal Dr. Satish Kamath to give introduction speech.
Good morning and namaste friends. I welcome all delegates in this online international conference. I also by heart welcome honorable resource person of this conference. Government of India and Maharashtra have issued orders of work from home due to COVID-19 and all citizens have responded to it positively. Arts and Commerce College Phondaghat has organized many activities such as online elocution and essay competitions, online national seminars, online international conference, online counseling center, online general knowledge quiz, etc. All sectors have been affected by COVID-19, including education. The government will solve the issues of examination, admission and syllabus in forthcoming days. The future is very tough and everyone has to face the challenge positively. We have to be ICT friendly and to accept novel teaching learning technology. I hope everybody will overcome this situation confidently and show our courage, consistency to the society. We have done a smart work during this period of lockdown and is also appreciated by our authorities. But we have to march a long distance without any pause. Robert Frost says, "The woods are lovely, dark and deep. The woods are lovely, dark and deep, but we have promises to keep. And meals to go before I sleep. And meals to go before I sleep." Thank you.
Thank you very much, sir. Now I announce Honorable Chairman of our society, Sri Srikant Apte, to give best wishes for this conference.
I am Srikant Apte, Chairman Phondaghat Education Society. Welcome you all in this online international conference arranged by Arts and Commerce College Phondaghat. Theme of conference is role of economy and ecology in sustainable development. I hope world will get out of COVID-19 problem soon and start moving again on the wheels of development. Wish you all great success and hope all delegates carry a lot from this conference. Thank you.
Good morning. The esteemed organizers of this one-day international interdisciplinary conference on role of economy and ecology in sustainable development, the esteemed speakers and delegates. Let me extend my sincere compliments to the Department of Economics, Geography and IQAC of Phondaghat Arts and Commerce College for organizing this one-day interdisciplinary conference in online mode. Friends, sustainable development is the need of time. It refers to the development that meets the needs of the present generation without compromising the ability of the future generations to meet their own needs. In other words, it's a process whereby the development can be sustained for generations to generations. The sustainability can be analyzed from different angles, maybe from human, social, economic and environmental. This one-day interdisciplinary conference is primarily analyzing the role of economy and ecology in sustainable development. Role of environmental in sustainable development can be cited in many ways. When you use recycled materials in the building of house, that naturally becomes an example of environmental sustainability. If you are using renewable resources, if you are designing the offices, buildings, so that you will have a complete utilization of the green concept, then that becomes an example of environmental sustainability. Use of biofuels in place of fossil fuel will not only support environmental system, but at the same time economy of the nation as well. Because if you refer to the fossil utilization of the fossil fuel in reference to our country, so we understand that much of our foreign exchange is utilized for buying fossil resources. So if we develop and utilize bioethanol, biodiesel in larger scale as a replacement of fossil fuel, then naturally that will become a good example of environmental as well as economic sustainability. Development of the electric cars, development of the hydroelectric power are other examples whereby economy and environmental sustainability can be easily combined. Any scientific interventions, any technological breakthrough, any new development needs to be analyzed always from the angle of sustainability, which requires life cycle analysis of the products developed through these scientific or technological interventions or developments. When you look at economic sustainability, then that requires definite planning, strategies and use of practices that support long-term economic growth without negatively impacting social, environmental and cultural aspects of the community. the links between the economy and environment in terms of sustainability naturally will be dealt in best possible way to this conference. In fact, sometimes one observes even a conflict between certain requirements. For example, if you think of biodiesel, which is definitely an ecological sustainable development, but when you analyze the use of raw materials for biodiesel, which utilizes vegetable oils, and vegetable oils are required for food, so that becomes a conflict between ecological development and the food requirement of the human being. So there are so many different examples of environmental and economical sustainability. They, in fact, they will play a major role in shaping overall development strategies of our country in particular and global in general. I wish the organizers great success in organizing this interdisciplinary conference. I extend my sincere congratulations to them, and at the same time, I expect the delegates to participate effectively and actively. And at the end of this one-day interdisciplinary conference on role of economy and ecology in sustainable development, there can be definitely emanating recommendations which will be useful for the future sustainable development from the economical and ecological angle. Jai Hind, Jai Maharashtra.
Phondaghat Education Society's College of Arts and Commerce, Principal Kamat, convener of this webinar, Dr. Survase, members of the organizing committee, and distinguished participants. It's great pleasure to share the company of you, though in absence, so far this webinar is concerned, which was important topic, the role of ecology and economy in sustainable development. I congratulate you all organizers because of organizing this webinar in the most critical conditions, most unfavorable conditions. This theme is extremely important not from point of view of academic debate, but from point of view of the existence of the very human society, and for that matter, the Earth planet. According to me, there are a number of dimensions of this problem, but the one simple and most important dimension is unequal distribution of income. Today, according to the latest information, nearly 1% of the richest people of the world own about 50% of the total world's income, and 57% on the other hand control only 2% of the income. So far India is concerned, 1% richest people own about 54% of the income and 72% of the wealth. This highly unequal distribution of income creates totally distorted production structure, enormously using these renewable and non-renewable resources, particularly non-renewable resources, for the satisfaction of the affluent sections of the society, where the basic requirements and needs of the overwhelmingly large number of people remain neglected. That's why I would suggest that if we want to achieve the objective of sustainable development, we must pay attention as to adopt measures as best possible way how we could achieve inclusive development, where the importance and priority needs to be given to the satisfaction of the poor needs of the poor people rather than satisfying the superfluous wants of the rich. With this, I wish the webinar a grand success, and thank you very much for asking me to inaugurate this seminar, which I declare stands inaugurated. Thank you very much.
Hello, my name is Scott Kafora, and I'd like to thank the Arts and Commerce College of Phondaghat for inviting me to speak with you today. The topic I'll be speaking on is sustainability. My background is in architecture, construction, and manufacturing, and today I'm going to be talking about sustainable building projects that the organization I work with in Kolhapur, called Avani, the techniques that we're actually using here. Slide 1. Today I'm going to be speaking with you about seeing the world differently. Slide 2. The topic I'm going to be speaking about in technique is called Super Adobe, and the actual product we built is called an Ecodome. Slide 3.2. So if you notice in this particular slide, I've given you CalEarth's website, but what they decided to do is to come up with what materials are readily available in emergency situations. So if it was an earthquake, a war zone, or a flood, the most common materials are sandbags and barbed wire. And if you look at this particular image, you can see these are the materials that they're actually working with. Slide 4. Now, as far as building a dome, they had also come up with one of the stronger shapes. It's called a catenary curve, as you can see in this particular illustration. It's not actually a perfect half dome or a half circle, but to give you an illustration of this particular point, if you have a string like this, stretched out like this, and you actually are letting it dip, that particular shape, if you invert that between those particular spaces, is called a catenary curve, and that is a very strong shape. Slide 5.2. Now, in order to build this particular ecodome out of soil, it's very important we're trying to limit the amount of concrete being used at this particular point. So you need to gather certain materials. To actually form the mud that we're going to be using, or slurry, you need a base of soil. You need some type of an aggregate like sand or small stones, and some type of a binder. Slide 6.2. So in this particular slide, you see the 3 samples that we actually have here. And what we would do, we do a compression test. We would take the same mold, and we would put this particular square sample under pressure after 7 days, after 14 days, and after 21 days to determine the compression strength of the mixture we were coming up with. Slide 7. And we also measured the weight of each of these blocks just to try to determine the density. Slide 8. So going out to the site, we wanted to test one of these domes. So we were going to build a 10-foot diameter dome. Now again, this particular shape is a catenary curve for the outside of the building, but the actual floor plan, the plan view, is actually a circle, which is a very strong shape. So if you look in this particular image, you can see where we've etched this on the ground, allowing for a 10-foot diameter interior space. Slide 9. Next, as you can see here, we needed to build a plinth. So we actually excavated into the earth, and we're going to build a plinth that's going to be about 0.75 meters off the ground. Slide 10. Once we've completed the plinth, we needed to put a very simple base of concrete just to kind of stabilize it. Slide 11. As I had mentioned before, the 2 main materials we're going to be using for these domes are poly bags, the type of bags that when you buy rice, you get these plastic bags in. The interesting point to this is you need a lot of this, and you need it in a roll. As you can see here in this delivery truck, it comes in lengths of about a half a kilometer in length. We use 2 different size bags, but this is showing the bags actually being delivered to our site. Slide 12. Now, as you are preparing to do the first course, to actually make this particular dome, you need to walk it off. So the first course of this particular dome, as you'll see here in a moment, it was 10-foot diameter. So this particular person has rolled out the bag on the ground and is actually walking off to measure it. Slide 13. Now also, barbed wire is going to be used in this particular process. It's a little complicated to be able to uncoil this. So we basically built a decoiler, a very simple system of 3 pieces of metal, so we can kind of unroll it like you'd unroll maybe a roll of toilet paper. This makes it much easier to be able to measure the length of the barbed wire you're going to be using. Slide 14. This is showing as far as the different soil samples that we're going to be using, as well as some of the foundry sand that we're going to be using as a binder. You need to make sure that you have this set aside so you'll be able to mix it efficiently. Slide 15. Once we've had about a week to let the plinth dry, We set up our camp here. As you can see, they're getting ready to start working on the first layer. The first thing that we did here in this image, you can see, are the steps. So they filled the bag with the soil. I'm going to show you here in just a moment of how we actually do that. Slide 16. So now you can see the first layer, the first coil has been completed. And what we're doing here is we've made a mixture of the soil, the sand, the aggregate that we've determined is going to be strong enough. Once it hardens, it's almost as strong as concrete. It's almost as hard as concrete. But you actually have to fill the bag. Now also here, you'll see in the middle of this image, you're going to see a pole. And what this is going to this is going to allow you to actually measure the diameter, the circumference, as far as of the dome on the plan. But actually, as you're actually adding the other layers to this dome, it allows you to cut the angle for the actual walls. So we're actually using this is called a plumb line, and it's also called a string line. And that becomes very important, you'll see in some other images here. But if you look closely at this particular slide, you'll also see one line of barbed wire. The reason we did that, there's not going to be any mortar between the layers. So the next layer we're going to put on top of this, which will be heavy, we're going to tamp it. We're going to fill the bags with the soil. We have about a 40-pound tamp. We tamp it into place, and it makes it very flat. It pushes out the moisture, and it flattens out this particular course. Then we surround it with a ring of barbed wire, and we put the next course on top of it, and that prevents lateral shifting. It does not require any mortar between them. So each layer that we're going to put, we just put one coil of barbed wire, and this will prevent the different courses from shifting. Slide 17. Now here we need to actually make an entry, entrance into this particular dome. We were actually using this as an experiment. This is going to be a guard station for one of our sites. But to do this, you need to buttress it. So we actually had some formwork done. We had this fabricated out of MS steel, and that's going to be the entry door, and we're going to build up to that, and that's called buttressing, how we're actually going to enter into this dome. Slide 18. Now, something else that's important for this particular dome is going to be ventilation. So at different courses and different levels, we're actually putting about a 5-inch diameter PVC pipe. We're going to be putting that into the wall, but we're angling it at about 10 to 15 degrees. The reason for that is when the monsoon comes or the rains come, they won't actually blow into the building. If it was perfectly straight or angled up, the water would come into the building, but we calculated about a 10 to 15 degree angle will prevent that. 19.2. Now, if you look at this particular slide, you can see that the exterior walls are starting to angle in a little bit. This is that cantilevered curve I was telling you about, where it's going to be angling a little bit. You can also see how we're building up the walls next to the entrance. We're buttressing against that. That is going to strengthen it because we're going to take out that formwork here in a couple of days. Slide 20. Now here you can see we've actually put the roof over that particular entryway and stuff like that. We still have a couple more courses to go to finish the dome, but the actual entryway is finished. After about 27 days, to let it cure and to dry, we can actually pull that formwork out. Slide 21.2. Now it's been about 27 days. We have removed the formwork. You can see the entrance, and the roof over that entrance can support itself. It needs about 27 days to dry to secure, just to be a little bit solid. But we're also going to need 90 days to let the whole structure to actually cure and be together. The problem that you have here with these particular bags is ultraviolet light from the sun. If it's exposed or left exposed to the sun for about 3 months, it'll start to disintegrate. Slide 22. So I designed this particular project where we would end and be able to finish the construction of this dome right before the monsoon. So in this image you can see I have covered the dome, and it will be covered for the 3 to 4 months of the monsoon. Slide 23. This is now 3.5 months later after the monsoon, and we're actually pulling the bag off the covering for the first time to see how well the structure has survived the water. 24. It turns out that the dome did extremely well. We had no ultraviolet light as far as damaging the bags or starting to break them down. But something that's very important in constructing this particular building is we use no chemicals, no petroleum, no oil, and very little concrete, maybe about 5% concrete in the mix and such, because the soil we want it to breathe. So on the inside of this dome, I had shown you the venting that we're going to be doing. I put those vents all around this particular dome, northeast, south, and west. So no matter which degree or angle the wind is coming, it'll actually blow into the building and the heat will be removed at the top, and it cools the building. But if we're using natural soil and no chemicals, this soil actually absorbs the moisture. So we can absorb as much as 5 to 10 degrees of heat within there that keeps it cool. So it's extremely important to use all natural materials and no chemicals. So in this particular slide, we're looking at what type of binders, what type of natural adhesives we can do, because we want to put a soil plasterwork on the outside of the dome. So here, one of our laborers, he's doing his first test to see an adhesive, and we're seeing if this will work. Slide 25. So here he's trying his first scratch coat, and it turns out this one didn't work so hot. We weren't real impressed with this particular technique. We were able to remove it easily and continue to work with different techniques. This is all experimental. This particular technique had not been built or constructed in India before, so it was a learning experience. We had time, we calculated it would take some time to learn the right type of materials we could use that would make this building fully sustainable. Slide 26. So here we're working on probably about the 5th different mixture to see if this would actually adhere, and this one worked much better. Slide 27.2. Now in this particular slide, we decided to introduce cotton fibers into the mixture for our main plasterwork. This would allow it to bind a little bit stronger, hold it together, and a little bit of flexibility. Slide 28. Now here, we're using the first mixture of this particular plaster with the cotton fibers, and it worked extremely well. Slide 29. But to give it a second coat, which would allow it to be even stronger, we actually put a mesh on this particular structure. We didn't use a metal mesh, we used a plastic mesh that would actually not decompose, and this gives it a little bit further strength and allows the plaster to hold and bind a little bit better. Slide 30. In this slide, you can see kind of our first test in the middle of this particular dome, and this particular mortar and plasterwork didn't work really well, so we ended up having to chip this out and try it again. Slide 31. After additional experimentation, we did come up with a plaster mixture and the actual mesh binding that allowed it to adhere to the structure much better, as you can see here. Slide 32. And here is the completed dome after our plasterwork has actually been done for the dome. We are going to paint it with a natural resin and colors, but we're actually going to be leaving it another 30 days to actually dry. It won't be gray, but this is the completion of this particular structure. Slide 33. As I had mentioned to you before, this particular technique is a technique by an organization in California, in the United States. There's an NGO called CalEarth, for California Earth. Their website is located on this particular slide. And you can see this is a slide showing some of the other type of domes that they're using. This dome technique works very well in dry, hot, arid climates. Well, here in India, especially in Kolhapur during the monsoon, is quite moist. So we had to add some revisions to the designs, different type of techniques to help it to be waterproof. But these next few slides, I'm going to show you some of the domes that had been completed in California, where it's very dry, it rarely rains, so it has a different technique, it's more of a sandy condition. Slide 34. So you can see in this particular slide, they actually are making like half domes. You can also use these bags to make benches, you can use it to make flooring and pavers, and there's many different techniques you can use for this, just using the soil. Now here, they actually removed the bags. Once the mortar had been, the mixture had been allowed to dry, and cure for 3 months, they actually cut the bags off and left it just regular soil, and it's like concrete. Slide 35. Again, this is showing some of the different techniques and different types of proportions you can do with the domes. Again, you can make a half dome. These can be smaller, just kind of little retreat areas and such, and you can see what they did with one of the bags. They kind of undulated it, and they made a bench from that. Slide 36.2. Now in this particular photo, you can see they've line several of these domes. So you can have different types of designs and configurations where you can have multiple domes working together. You can have them in a group. You can have them in a courtyard. You can see that they've used this technique to actually build the courtyard, to build the benches, to build the entries, to build the domes, and all of this can be done without an architecture or engineering background. It's just limited to your creativity and your imagination. Slide 37. Something else that CalEarth works with is called permaculture, working not just to build the building and just drop it on the site, but also working with nature. So they also use this technique of these particular bags to make benches. And these benches can actually become planters as well. A very creative technique where you don't need any type of brickwork, any type of concrete work to make the planters and benches. Slide 39, continuation part 2. Now the first dome that I had shown you earlier was about a 10-foot diameter dome. Any larger than that, you will need to buttress the walls. The same as the entrance to that dome, I had to actually have a metal form to buttress against, otherwise it would collapse. A larger dome will need buttresses to actually hold it together. So in this particular image, this is a drawing that I put together of a larger dome, about 15-foot diameter interior. So I'm going to have about 3 or 4 smaller domes integrated into it, around it, that will hold it together. Slide 40. Now here's more of a 3-dimensional view of that. I basically cut the dome in half so you can actually see where the different air vents are. Again, the ventilation of this dome is extremely important. I have the vents facing northeast, south, and west, all 4 degrees. So no matter which direction the wind is coming, it'll actually come into the building, and all that heat will basically dissipate through the top. Slide 41. This is another one of my sketches showing you the progression from the actual floor plan to the actually foundation of how high we're going to be building it up to actually start building the walls. In the back of this image are my first sketches as far as the massing of what I thought this dome would look like. As I started building it, it changed a little bit. Slide 42. Here's an enlarged view of what my first sketch for the final dome would look like. Slide 43. Now this is showing a cross-section of the building. I wanted to make sure that the heights inside would be conducive ergonomically for a human. You can actually see that. On the right side, you can see I have that smaller dome that is buttressing the larger dome. This will actually become a bedroom. This is actually where you can put a bed. It can be a storage room. It can be a washroom. It could be a small kitchen. Anything you actually want to do with that. But this particular structure, we determined we needed 4 smaller domes around it. One of them would be the entry, allowing you the flexibility of 3 additional domes. Slide 44. So now you can see the larger footprint of this particular dome. We completed the plinth here. So you can see we're actually going to be building 5 domes. The larger dome and 4 smaller domes that are going to tie into it. So we're going to need 5 different poles. That way we can measure the diameter of each of these. We can also measure the angle of each of these. Slide 45. Now I'm also going to need windows and some entry door spaces inside. So I had metal fabrication done in both catenary curves and half arches for the interior door and window openings. Slide 46. Now this is probably about 2 weeks into the construction, and now you can see how we've tied this together. This is about 1.2 meters in height, but you can see how the smaller domes are actually tying into them. They're woven into them. We're also putting, again, those vents inside, and you can see that I'm using the same formwork for the entry doorway to buttress. Slide 47. In this particular slide, you can see on the right side that we're actually collecting dirt from the site. We're mixing it in the mixer, putting it in buckets, and taking it up to actually complete the actual pouring in the bags. Slide 49. In the next 4 slides, I'm going to show you how we actually fill the bags. So in this particular slide, you can see one of the volunteers from CalEarth is actually at one of the bags, and he's getting ready to fill it with soil. Slide 50. One of the other volunteers now has one of those buckets of soil, and he's pouring it into the bag. Slide 51. And you can see the volunteer on the right, he's now lifting up the bag and having the soil actually come down. You can also see that there are multiple people on here handing the buckets, so we have kind of like an assembly line bringing the buckets of soil to the person filling the bag. Slide 52. Here, once we get to the end of a wall or where it's going to be connecting into another wall, they actually have to tie the bag at the end. So it takes a little bit more time and creativity to be able to tie and secure the bag where it actually ends. Slide 53. Now you can see one of the Cal Earth volunteers, he's actually measuring with our string line to actually see the diameter, to make sure that the diameter of this is perfectly circular. That adds to the strength. Slide 54. Now this slide shows you the tamp I was talking about. Once we filled the bags with the soil and we've tied it off, this person is actually taking this. This is about, I'd say about a 15 kg piece of equipment that we're using, and we tamp it, and this actually levels, it flattens the actual bag, it pushes it out into the corner, any moisture, and it makes it much stabler. Slide 55. Now here you can see one of the volunteers, he's actually got the two string lines, one to actually measure the diameter, and the other one to measure the angle of the roof. Slide 56. This particular image is showing you how we supported the opening. This is going to be one of the doors on the right, and how we had to have the formwork there before we put the bag so they can actually go over the formwork. Slide 57. And here you can see it's very complicated to actually put the barbed wire. It's very difficult to work with and to bend. You have to wear special leather gloves to do this, and it's very time-consuming. This is probably one of the more time-consuming processes. If this is done correctly, it'll make sure that this building, none of the bags slide. Slide 58. Now here you can see we actually have two rows. This wall is actually about 10 inches wide, and so we actually have to have two different rows of the barbed wire to make sure that there's no shifting here. Again, you can see how complex it is done. This has to be done correctly and scientifically. Slide 59. This is showing a little bit more some of the other entrances. You can see how the smaller dome is tying into this and how the barbed wire ties into that too. Slide 60. These next two slides, you can actually see this is the door opening and the window opening. It's been about a month. It's had time to cure. We're able to take out the formwork, and it's strong enough to actually support the opening. Slide 61. And here's one of the windows. Now, I placed the windows very specifically facing to the north and to the east. I had no windows facing to the west or to the south. That's where the primary, the winds and the rains will be coming during the monsoon, and this will allow us not to have any type of issues with water coming in the building. Slide 62. Getting close to completion, you can see how all this is actually tying together, and you can see as these domes are getting completed toward the top, they're actually starting to angle in. That will prevent water from collecting during the monsoon season. Slide 63. Now this view is actually facing to the north, and you can see kind of the massing, how we actually had built this on the plinth. You can see how it's coming together and how each of these different courses, these layers, are tying together to support each other. Slide 64. Completing one of the smaller domes, we actually leave a hole at the top. We're going to be putting a PVC pipe with an angle on this, actually a curve, that will actually allow the heat to come out. We're going to face it away from the prevailing winds when the monsoon comes, so no water will come in, but this will allow all the heat and all the air that's actually accumulating inside to be able to vent out the top. Slide 65. This is actually the last day of construction. We're finalizing the larger dome. We've already finished, completed the smaller domes, and this is kind of giving you the massing of what it's looking like. Slide 67. And now the volunteers are installing the last course. This will be the last one we're putting on here before we actually put in the skylight. Slide 68. Here is a view of the completed dome on the inside, at least the bag work that we're doing. We are going to put plaster on this, but this kind of shows you from the entry looking up and the skylight. Now the skylight will let a lot of natural light into this particular building because I only have two windows. Slide 69. Here is the completed bag work done for the dome before we're actually going to cover it for the monsoon and add plaster later. But you can see the shapes of how proportional they are to each other, how they actually are tying each other in. Slide 70. So now you can see where we've located our dome on our 5-acre site. This is pretty much in the middle of the property, and you can see how it's actually going to be blending in with the landscape. Slide 71. Now it's been 3 months later. We've gotten through the monsoon. We've taken the bag work off of the dome, and we're doing experimenting again. What we learned on the smaller dome, some of the plaster techniques were good, and we wanted to improve upon it. It's a larger dome, so we started experimenting with different types of stone and dirt and soil plaster work. Slide 72. Here you can see the monsoon has just ended, and we're starting to do some of the plaster work, doing some experimentation along the bottom. Again, there's a lot of experimentation, a lot of techniques you need to try before you get the exact mix that you're looking for. Slide 73. And so now, once we have decided on the proper plaster work, we've actually put the mesh work on there as well. And this is what the building would actually look like once all the soil work is done. It will still need another 30 days to dry and to cure. Slide 74. And we end up using the same soil. It's kind of a reddish-orange soil from the site. We use this as our base coat as far as for the dome. And here's what the completed dome ended up looking like. Slide 75. And here's what the interior is looking like as well. Many different ways that you can finish out the interior and exterior of the building. But again, as I mentioned, it's very important that you use natural materials. Since we use soil on the inside and the outside, no matter how hot it is outside, any moisture will be absorbed into the walls and it allows it to naturally ventilate. I want to thank you for your time and attention in listening to this particular presentation of our Eco-Dome. Again, this is something that I have designed and built and constructed for the Avani organization in Kolhapur. The Avani organization, we work to rescue child laborers. And we actually have several children's homes, and this is one of the projects that we use to house some of those children. If you have any questions, please feel free to contact me anytime on my email address. Thank you for your time.
On behalf of our college and Phondaghat Education Society, I sincerely thank all resource persons. Now I request convener Dr. Balaji Surose to propose vote of thanks.
Good afternoon, myself Professor Dr. Balaji Surose, on behalf of Department of Economics, Department of Geography and Department of IQAC of Phondaghat Education Society's Arts and Commerce College, Phondaghat. I sincerely thanks to all the resource persons who have taken lots of efforts to deliver their speeches. I also very much appreciate these talks. Thanks to all. I express my thanks to Phondaghat Education Societies for their encouragement. Dear participants, without your active participation, it was not possible to complete this international conference successfully. Thanks to all. I also thank our principal, Dr. Satish Kamath, for his support and continuous guidance. This international conference is grand success only because of Dr. Rajaram Patil, who has taken lots of efforts. I also thanks him. I thanks our teaching and non-teaching staff and technical team also. With the permission of our principal, I declare that conference is over. Thank you one and all.